The Goldbach conjecture is one of the oldest unsolved problems in number theory. The modern version of Goldbach's conjecture, called Goldbach's strong conjecture, is this. Every even integer greater than 2 can be written as the sum of 2 primes. For example, 4 can be written as 2 plus 2. 6 can be written as 3 plus 3. 8 can be written as 3 plus 5. 10 can be written as 3 plus 7 or 5 plus 5. 12 can be written as 5 plus 7. 14 can be written as 3 plus 11 or 7 plus 7. And 16 can be written as 3 plus 13 or 5 plus 11, etc. For small values of number, the strong Goldbach conjecture can be verified directly. With the advent of computers, many more values have been checked. T. Oliveira e Silva is running a distributed computer search that has verified the conjecture held up to 4 times 10 to the power of 18 on the 4th of April 2012. In spite of its simplicity, there is no method for proving it known today. There are plenty of ways to support the conjecture, but no method guarantees that it will never fail for a given number. Christian Goldbach is a German-Russian mathematician who contributes to number theory, including the famous Goldbach's conjecture. He also studied and proved some theorems on perfect powers, such as the Goldbach-Euler theorem, and made several notable contributions to analysis. Christian Goldbach was born on the 18th of March 1690 in the Duchy of Prussia's capital Königsberg. He was brought up in Königsberg and attended the university there. After finishing his studies at the Royal Albertus University, he went on long educational voyages from 1710 to 1724 through Europe, visiting other German states, England, Holland, Italy and France, meeting many of the leading scientists on his travels, such as Gottfried Leibniz, Leonhard Euler, and Bernoulli's family. Back in Königsberg, he got acquainted with Georg Bernhard Bulfinger and Jacob Hellmann. He went on to work at the newly opened St. Petersburg Academy of Sciences in 1725. Later on, he became a tutor in 1728. Goldbach died on the 20th of November 1764 at age of 74 at Moscow. A superb command of Latin style and equal fluency in German and French, Goldbach's polished manners and cosmopolitan circle of friends and acquaintances assured his success in the elite society. He is most noted for his correspondence with those well-known mathematicians, especially in his 1742 letter to Euler stating his Goldbach's conjecture. In the life of Goldbach, he had a great friend in his studies, Euler. He was a pioneering Swiss mathematician and physicist. He made important discoveries in fields as diverse as infinitesimal calculus and graph theory. He also introduced much of the modern mathematical terminology and notation, particularly for mathematical analysis. One day, Goldbach had a new idea about numbers. On the 7th of June 1742, Goldbach wrote a letter to his friend Euler, proposing that every integer which can be written as the sum of 2 primes, can also be written as the sum of as many primes as one wishes, until all terms are units. Scrawled in the margin of this letter, Goldbach also proposed the following. Every integer greater than 2 can be written as the sum of 3 primes. Of course, it is worth noting that back in Goldbach's day, 1 was considered a prime number, which is now generally no longer the case. As such, modern formulation of Goldbach's statement would be, every integer greater than 5 can be written as the sum of 3 primes. After reading this letter, Euler responded on the 30th of June 1742 by pointing out to his friend that it followed from his original proposition that every even integer greater than 2 can be written as the sum of 2 primes. And thus what is now often termed the strong Goldbach conjecture was born. Equally, from this it follows that every odd number greater than 7 can be expressed as the sum of 3 odd primes. This has since become known as the weak Goldbach conjecture. Until death, the great mathematician Euler still cannot prove it. Since then, Goldbach conjecture has become a problem that attracted thousands of mathematicians' attentions. However, no one succeeded in proving this conjecture.
Shout across the lines. I don't wanna go to sleep either. 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 I don't wanna go to sleep either.
Over 100 years' silence, thought drew attention from thousands. Firstly, what is the definition of the term A plus B in proofs of Goldbach's conjecture? Mathematicians use this term to represent the idea that all large even integers are the sum of two numbers, of which one is the product of A prime numbers, and the other one is the product of B prime numbers.
I don't wanna go to sleep either.
1920, Norwegian Bruin proved 9 plus 9, namely, all large even integers of the sum of 2 9 are smaller almost primes. In 1924, German Hans Rademacher proved 7 plus 7. In 1932, British Esterman A. Sturman proved 6 plus 6. In 1937, Italian Ricci Tracy proved 5 plus 7, 4 plus 9, 3 plus 15 and 2 plus 366. In 1938, Russian Baiksrao proved 5 plus 5 and in 1948, he also proved 4 plus 4. In 1948, Hungarian Rini Rainey proved 1 plus C, where C is a large natural number. In 1956, Chinese Wang Yuan proved 3 plus 4, and after 1 year he proved 3 plus 3 and 2 plus 3. In 1962, Chinese Pan Chengdong and Russian Bapo proved 1 plus 5. In 1962, Chinese Wang Yuan again proved 1 plus 4. In 1965, Russian Baiksrao and Bipape Vinogradov, together with Italian Bombieri Billy proved 1 plus 3. In 1966, Chinese Chen Jingguan proved 1 plus 2. Chen Jingguan showed in 1973, using the methods of sieve theory, that every sufficiently large even number can be written as the sum of either two primes, or a prime and a semi-prime which is the product of two primes. Chen's theorem is a giant step towards the Goldbach conjecture, and a remarkable result of the sieve methods. Finally, how about 1 plus 1, which exactly what the Goldbach conjecture is about? For application. Actually, there are not many direct practical applications of Goldbach's conjecture, as it is still not proven yet. In order to verify or prove the conjecture, new techniques in mathematical problem solving will be developed in the process, and the techniques will be actually applicable. Although the applications of Goldbach's conjecture are not found yet, this does not mean there won't be any. Let's take calculus as an example. When calculus was discovered, it was considered useless also. But now, calculus is used in almost every branch of physical science, actuarial science, computer science, statistics, engineering, economics, business and so on. Perhaps, like calculus and many other mathematical problems, the applications of Goldbach's conjecture are unforeseen but will burst out. It's also possible that Goldbach's conjecture is just a spark on the history of mathematics. The journey of discovery is particularly meaningful.